Good morning. Myself Dr. K. Kannan, working as a professor in the Department of Mechatronics Engineering, Kamaraj College of Engineering Technology, Virudunagar. I welcome you all to this video lecture on the topic characteristics of sensors used in automobiles. We already know there are so many sensors are involved in the sophisticated automobiles. We will discuss the characteristics of sensors used in the automobiles. Sensors, we will use the term sensors as well as transducers interchangeably, but there is a difference between the term sensors and transducers. The term sensor is used for an element which produces an electrical signal relating to the quantity being measured. Example for sensor is RTD, resistance temperature detector. Here the function of the RTD is to detect the temperature. So, based on the temperature being measured by the RTD, the resistance of the RTD will be varying one. So, the function of the sensor is to convert any physical parameter into its equivalent electrical signal. The electrical signal may be in the form of voltage, current or power. Here the RTD is a primary sensing element which converts the measuring parameter temperature into change in the resistance. The change in resistance may be converted into the change in voltage by the secondary sensing element. Whereas the term transducer are defined as elements that when subject to change they will experience a change. For example, spring is a transducer. The input to the spring is the physical parameter force. So, based on the application of force, the length of the spring may be elongated or compressed. Okay. So, here the function of the transducer is to convert one form of energy into another form. In the sense, all the sensors may be called as transducers. Anyway, we can use both the terms sensors as well as transducers interchangeably. If the output of the transducer is electrical signal, at the time the transducer is said to be the sensors. The sensors as well as transducers may be analog or digital. So, based on the nature of the output generated by the sensors as well as transducer, we can classify the sensor or transducer as a analog one or a digital one. If the output is analog, that means the output is changing with respect to time, continuously varying parameter. At the time the sensor or transducer is called as analog. Whereas if the output generated by the sensor or transducer are analog in nature or it changes its value at discrete instant of time, at the time it is said to be the digital one, digital sensor or digital transducer. So, based on the output generated by the sensor and transducer, we are classifying the sensor as either analog or digital one. Okay. All the natural sensors and transducers are analog in nature only. But suppose if you want to process the output from the sensor or transducer using the computers, at that time there is a need to convert the analog signal generated by the sensor or transducer into the digital one. For that only we are integrating the analog to digital converter with the sensor as well as with the transducer. At that time the analog sensor or transducer is said to be the digital sensor or digital transducers. Sometime there is a scope to integrate the signal conditioning circuit as well as the microprocessor with a sensor or transducer. At the time the sensor or transducers are said to be smart sensors. Nowadays the most frequently available sensors available in the market are smart sensors only. And these are the characteristics of sensors used in automobile industries. We can have two types of characteristics. The first one is said to be the static characteristics of sensor, the second one is said to be the dynamic characteristics of sensor. Static characteristics are nothing but the characteristics of sensor when the output of the sensor reaches a steady state value. The static characteristics are range and span of the sensor, error, accuracy, sensitivity, hysteresis error, nonlinear error, repeatability and reproducibility, stability as well as dead bond. Whereas another set of characteristics are called as dynamic characteristics. Dynamic characteristics are nothing but the characteristics of sensor when there is a change in the output, or the characteristics of the sensor before the output reaches the steady state value. At the time these characteristics are said to be the dynamic characteristics, and the dynamic characteristics are response time, time constant, rise time as well as settling time. So we will discuss all the characteristics one by one. The first static characteristic of sensor is range as well as span. The range of the transducer or sensor defines the limit between which the input can vary, whereas the span is the difference between the maximum value of the output generated by the sensor and the minimum value of the input. For example, for a load cell, if the load cell is used to measure the force up to 10 kilonewton, then the range of the load cell is said to be 0 kilonewton to 10 kilonewton, and the span is nothing but the difference between the maximum value and the minimum value. Here the maximum value is 10 kilonewton and the minimum value is 0 kilonewton, so the span is 10 kilonewton. Like that, the error is nothing but the difference between the measured value and the true value of the quantity being measured. Suppose if you are using one temperature sensor to measure the temperature, it shows the output value of 26 degrees centigrade, but the actual temperature is 27 degrees centigrade. At the time error is said to be plus 1 degree Celsius, whereas if the sensor shows plus 20 degrees centigrade as the output value, but the measured actual temperature is 25 degree centigrade, then the error is minus 1 degree centigrade. The next static characteristic of sensor is accuracy. Accuracy is the extent to which the value indicated by a measurement system might be wrong. It is an affordable value. Sensitivity, the sensitivity is the relationship indicating how much output there is per unit input. That is nothing but the ratio of output to the input. So sensitivity is defined as the ratio of output to the input. The next characteristics of sensor is hysteresis error. The transducers can give different outputs for the same value of quantity being measured according to whether that value has been reached by continuously increasing change or a continuously decreasing change. This effect is called as hysteresis error, and the hysteresis error is the maximum difference between these two curves. In the graph shown here, the value of measured quantity is plotted in the x axis and the output from the transducer or sensor is plotted with respect to the y axis, and here we are increasing the input value from 0 to maximum. So we are getting the curve like this one. So this curve is got when we increase the input from the lowest value from the lowest value to the highest value. Suppose after reaching the highest value, if you reduces the input so that the input reaches the minimum value, at the time you will have another one curve like that only. So the maximum difference between these two curves is said to be the hysteresis error. Non-linear error. Always there should be the linear relationship between the input and the output variable of the sensor, but due to non-ideal characteristics we will get this non-linear error. Non-linear error is nothing but the error due to the non-linear relationship between the input and output, and in this slide I have shown three types of non-linearity error. It is based on how we are plotting the straight line which connects the minimum value of the input and the maximum value of the input. The straight line was plotted in the first method using connecting the 2 points, minimum value as well as the maximum value, whereas the second one is fit using the best fit curve technique. Okay. And the next static characteristics of the sensor is repeatability as well as reproducibility. Repeatability as well as reproducibility both are the ability of the sensor to provide the same output value for the repeated application of the same input. Stability is nothing but the ability of the sensor to give the same output value for constant input over some period of time. It is called as stability. Dead band, for certain level of minimum input there won't be any output from the sensor. That input range value is called as a dead band. So dead band is a range of input for which there is no output. So far we have discussed about the static characteristics of the sensor. Next we will discuss about the dynamic characteristics of the sensor. As I already told, there are 4 dynamic characteristics of the sensor. They are called as a response time, time constant, rise time as well as settling time. Here the response time is nothing but time taken by the sensor to generate 95% of the steady state value after the input is applied, whereas the time constant is nothing but the time taken by the sensor to produce 63.2% of the steady state output after giving the input. The rise time is nothing but another time parameter. It is a time taken by the sensor to generate the output to 90% of the steady state output, whereas settling time is taken by the sensor to reach the 100% of the output value. So these 4 are the dynamic characteristics of the sensor. This slide shows the different sensors used in the automobile industry for the implementation of digital engine control system. The digital engine control system is preferred over the conventional engine control system for 2 purposes. The first one is to maintain the fuel economy. The second one is to reduce the amount of pollutants in the exhaust emission. Here various sensors are used. The first one is the MAF sensor. It is nothing but mass airflow rate sensor, which is used to provide the direct measurement of amount of air entering into the cylinder. The next one is a throttle position sensor. It will give the amount of opening of the throttle plate. And the third one is the differential pressure sensor, DPS sensor. It is nothing but another one sensor used for the indirect measurement of the amount of air entering into the cylinder. So these 3 sensors gives the exact amount of air entering into the cylinder. So based on the amount of air entering into the cylinder, the fuel injector will pump the amount of fuel required for the proper air fuel ratio mixture. CT is nothing but the coolant temperature sensor. It is nothing but a temperature sensor. RPM is a engine speed sensor. HEGO is a heated exhaust gas oxygen sensor. It will measure the amount of oxygen present in the exhaust emission. EGR valve is an actuator used to recirculate some of the exhaust gas, like that. So these are the variables to be measured to maintain the fuel economy in a digital engine control system. The first one is mass airflow rate sensor. The next one is exhaust gas oxygen concentration sensor, throttle plate angular position sensor, crankshaft angular position or RPM sensor, coolant temperature sensor, intake air temperature sensor, manifold absolute pressure sensor, differential exhaust gas pressure sensor, and vehicle speed sensor, and transmission gear selector position. So for measuring these variables in an automobile, we will have different types of sensors as shown in this block diagram. Here I grouped the different types of sensors used in the automobiles into 3 categories. The first one is the types of sensor used in power drain, that is for transferring the engine power to the wheels, are airflow rate sensor, air fuel ratio sensor, camshaft motion sensor, coolant fluid level sensor, crankshaft motion sensor, detonation sensor or knocking sensor, exhaust oxygen sensor, manifold pressure sensor, oil level sensor, oil temperature sensor, throttle position sensor, transmission output speed sensor, and transmission temperature sensors. In the driving aids, we will use the sensors like accelerator position sensor to measure the amount of pressure applied on the gas pedal, and working of the anti-lock braking system, and cameras, radar, ultrasonic and infrared sensors, steering rate sensor, tactile sensor, as well as vehicle speed sensor. For safety and comfort, the sensors like brake fluid level sensors and compartment temperature and humidity sensor, door position sensor, electronics monitoring and diagnosis sensor, outside condition sensors, ride comfort sensor, tire pressure sensor, and a washer fluid level sensor. These sensors are used. Thank you.